Hello and welcome back to Innovation Insights. Today I'm here with Ruairidh Battleday, who is joining us all the way from Boston. So thank you, Ruairidh, for being here and welcome.
Thank you. It's a pleasure to be here, Victor. And although I was just told Boston isn't that exotic for CIC, it is. I learned half the world away. And so I'm just getting used to the jet lag. So thank you for bearing with me.
Well, it's a wonderful location. We have a lot of visitors from Boston, and that's the reason it's not so exotic for us. But we are very happy of that connection between Tokyo and Boston, and we want that to happen more. So wonderful to have you here. Let's start the interview, and I wanted to start by asking you to briefly introduce yourself and tell the audience about your journey. What did you do to do what you do right now? And what are the exciting things you are doing now? Because it's very exciting and I want the audience to understand every piece of it, and then we can dig more into it.
At the moment, I'm an AI researcher at Harvard with an affiliation at MIT as well. At Harvard in the Center for Brain Science, MIT in the Center for Brains, Minds, and Machines. And alongside that, I'm the CEO of a nonprofit called Thinking About Thinking, which holds kind of high-profile summits on AI. But the question was about how I got there, and it's been a long history of me being interested in discovery and invention, and sometimes that's self-discovery and sometimes self-invention. And I think when you allude to a rather storied career leading up to this, a lot of my kind of 20s were about working out who I was, what I was interested in, and what I thought were the most interesting or important questions for the whole world. And so, as you mentioned before when we were talking, I had a brief period of being a biochemist, had a brief period of doing medicine, a medical doctor, went on to think about mathematics, computer science, and have ended up in this field of artificial intelligence, where a lot of the world is at the moment. And I think that a lot of the most interesting questions from the 20th century have sort of matured in the 21st. So in terms of how I got here, it was a lot of school, a lot of study, but also a lot of talking to people, traveling, understanding, who are we? What are we most concerned about? And trying to understand maybe how in different parts of the world they did things differently. And in that context, being here in Japan is very interesting.
And you mentioned you did the medical career and the biochemist, and you're a doctor to a medical doctor. And then you went into mathematics and get into the AI part where you are now mixing both, I guess, of them. Tell me more about that. I mean, what did you learn from the medical side, and what took you to AI, and how are you combining both of them as of now? I mean, what is leading into?
Yeah, it's a very good question. I mean, the simplest answer is I did medicine because my mother told me to. But a slightly more complex answer is that after my undergraduate, I knew I wanted to do a PhD and to kind of embark on a period of long research about an important question, but I couldn't decide what. And so my mum pointed out that there were these programs at the time in the UK, accelerated medical degrees, where the NHS would pay for you to study. And she thought I'd be around loads of interesting people. I'd maybe see the real world relevance of some of the science, and I'd have time to make up my mind on what I wanted to do my PhD in. And she was right. But along the way, I just gained this incredible richness of understanding the human fabric, the human condition, and what life and work is like as a practicing doctor. Now, I never really practiced, but in the final stages of medical school, you're in the hospital all day. Maybe you do a stint in another country. And there, what's very interesting is your whole world is focused on this person in front of you, giving them all of your energy and using both your IQ, but also your EQ to try and understand how to help them. And you would come home from a day of doing that absolutely exhausted. Yes. You just couldn't think about, or I didn't have the energy to think about these existential questions or kind of fundamental research. And eventually I began to miss that. Oh, right. For me, I felt like the most stimulating thing was chewing over a problem for a long period of time, but a problem where if you made a little bit of progress, you could change the world and maybe, help a lot of people. And so hence, towards the end of the medical degree, I began thinking a lot of these questions are finding the most interesting answers through the language of mathematics, statistics, computer science. And so that's why I went on to do a PhD eventually in computer science. But initially, I did a lot of pure math and things like that. And it was such a change after spending every day in the hospital.
Yeah, I mean, a complete difference. I mean, you are more in the abstract world when you were in the physical, literally physical world, right? So it's a complete different environment. And then you take it into AI, and then you finish your PhD, and then you now have an NGO that runs events on this globally, in San Francisco, Boston, London, and Tokyo, and probably more in the future. You also have a startup. You also are starting a fund, and probably you have other things. But tell me more about what is exactly what you are doing now with AI, and what is this ecosystem you are building around it?
Yeah, so I mentioned discovery and invention before, and we're at this very fascinating time in AI where it seems like it's able to have human level cognitive capabilities in some realms, like for example a chatbot, and yet other realms, perhaps like scientific discovery, we don't quite yet have AI that can do it. And so for me, this has been the most interesting and important question is how can we develop AI that has creative problem solving to the level of a good human scientist as a sort of edge case of human cognition, but also the types of things that we would love to automate to help humans in general. Yeah. So to make research on things like cancer biology, to help research on perhaps nuclear fusion. So a really exciting and motivating like set of technical challenges that I think requires a kind of multidisciplinary approach. So that's stimulating research outside of the traditional setting, where maybe some of these bigger projects would have fallen through disciplinary cracks. But I think it's also trying to identify like a wider range of stakeholders who might be interested in the application of such efforts in enterprise or in applications for social good. And so the different hats I'm wearing are all sort of painted the same color, you know, and that color is how can we develop algorithms for creative discovery and problem solving that we could use to subsequently help the world in a massive way.
Are you creating the environment for people to bring those algorithms and be there and be shared and be built one upon each other? And if so, how is that working in practice? And who do you reach out? How does it work? And how do you combine these pieces that you have?
Yeah, that's a great question. And it is forming, and none of us know the answer. But maybe a good analogy is like the birth of modern science. And so two kind of institutions that were seminal for the birth of modern science were the Royal Academies of Britain and France. And these were radical in their day. You know, the idea that people would come together, openly share ideas, critique ideas but in a constructive manner, and draw in resources from, at that time, the crown, but also sort of tax money to develop this, this new discipline of science, or they would have called it natural philosophy. And on Coleridge's suggestion, start using the word science about 50 years later. So the question now is, what is a new kind of institution that's necessary to do algorithmic science? And that's really what me and my colleagues and collaborators are concentrated on. And what we think it might require a different set of stakeholders from traditional academic enterprise. And so, one reason for that is it's likely at the moment it will cost a lot of compute. Yeah. Compute's very expensive. It's probably not going to be funded through universities. I think another thing that's been kind of growing in the 21st century is that there's really a plurality of voices that could contribute on big questions like these, but might not be suited to traditional academia. Yeah. So all of these different organizations are a way of sort of building a new meta organization in which these goals can be pursued and are considered successful on a number of metrics. So academically, but also economically and societally. Yeah. And I think that I've seen some really inspirational organizations and people striving that way. And I remain a kind of, not a naive, but a basic optimist in thinking that we should be trying to pursue using science, technology, AI to make the world a better place. And we can probably do that if we use different groups of people to build that. Yeah.
All right. So this is AI for science and problem-solving discovery and very, very complex challenges. And you mentioned that this is forming. Can you give me a tangible example of something that already has happened or is in the progress, but you have some results, something tangible for the audience to understand, okay, what does it mean exactly? What's the shape of this?
No, that's right. So so there are kind of a few different levels of AI for science. One level, which is exemplified by AlphaFold from Google DeepMind, is finding a problem that's been considered by the scientific community for many years, and sort of coming up with a machine learning model that can solve that problem. And AlphaFold has just been immensely impactful, and indeed the Nobel Prize was awarded for its discovery or creation. AlphaFold, it kind of relies on this extremely adept team of engineers and scientists working together to create the problem, and then a machine learning optimization algorithm generates, for example, it can read the string of amino acids that would make up a protein and synthesize its 3D structure. And that 3D structure is very important because it can then be used to design therapeutics for any sort of protein deficiency or abnormality. But it can also be used to sort of simulate biology on a larger scale. So I think that's an extremely important discovery that's happened, the discovery of AlphaFold. What we would also like is something like an AI companion for scientists. Yeah. So something that can help them, come up with new good ideas for studies to run, can help them sort of reconceptualize problems. And so we haven't seen something like that yet. It turns out that coming up with the problem to be solved is way harder than solving it. Yeah. And so for me, I'm not saying we have an answer to something like that yet, but that's a lot what me and my collaborators are focused on. That question of what is the human creative problem solving that a scientist does in coming up with big problems that could then subsequently be solved by machine learning. And so, a good example of that is something like Einstein's discoveries in his sort of miraculous year, where he came up with Brownian motion, special relativity, and general relativity in the course of 1 year. Could we design an AI system that could come up with vast conceptual changes like that, and radically accelerate, for example, a field like cancer biology, where there's been a huge amount of resource deployed, but maybe not that much progress, really.
All right, so this is fascinating, and I'm thinking, all right, we have some concept that is similar to this happening in the traditional, what people understand, consumer AI. Let's put it that way, the LLMs, right? And now we have the agents, and the agents is more like that companion. You have the Microsoft companion, right? It's called companion, but it tends to be that it's a co-pilot you have, but then it's the agent goes a little bit farther. You are programming something to learn about you and do something. It's more like the person that helps you, like an assistant that is there for you. So it seems you are taking this to a next level, but it's kind of a parallel way of the two worlds. How is this agent and agentic kind of technologies and development impacting development in this other side? It's completely different. It's a completely different set of problems. It's an exponential quantum loop that happened here. Leap, or is something else? It's something that you said, yes, it's coming.
It's a great question, and we're in August now, and so I think is 2025 the year of agents, or did it turn out not to be? And I think basically it's turned out not to be, and the reason I think that is because the agents that we're deploying in an enterprise setting or a scientific setting need a great deal of management to do kind of very simple things reliably. And so, the type of system I'm describing would be something that's a lot more autonomous and can sort of go away and solve problems or come up with problems over quite a long time period, using its resources and acquiring new ones in a creative manner. So I think, when we think of AI agents at the moment, maybe they seem a little bit like interns. You have an intern into your company, you have to onboard them, upskill them, supervise them, but they can help with work, and hopefully they learn enough to become something like an associate. And I'm sure anybody that runs a company, or even like a company of companies like yourself, wouldn't be too keen on the idea of bringing in an infinite number of interns. But the idea of onboarding a huge number of autonomous associates, that's very attractive. And so I think that's broadly speaking what AI scientists are going for.
You understand all of them. You are also talking with a lot of leaders around the world about this, from different backgrounds, as you're saying, multidisciplinary, all converging about the AI topic, its risks, its challenges, its opportunities. So I want to ask you that exactly. How do you see the vision of AI? Where is the most exciting things and opportunities that we are having in the coming three, and I'm saying 3 years because that's like 10 in normal technologies for AI. And what are the challenges that we have coming?
Yeah, thank you. And it's always important to think about the challenges as well. And so the summits that my nonprofit run are summits on open problems for AI. And they're thinking about the challenges not only in terms of the algorithmic advances, but also for society, for enterprise, for entrepreneurs. But I think the great hope is that we will have personal agents that can help rid our lives of some of the horrible digital bureaucracy that we've acquired over the last 20 years. So we would like, once we've worked out how to solve a problem on our computer or do something that could be automated or repeated, we would like to just ask our personal AI assistant, could you now do this for me? I don't want to think about it again. And I really do think in 3 to 5 years we'll have systems that can do that in a very flexible way. Could actually finally schedule things with multiple people on your computer, could sort of draft answers to emails. So I've been feeling like a massive potentiality is like ridding ourselves of the digital ills that we have inadvertently acquired of our technology advancing maybe a little bit faster than society's ability to deal with it. And so I really hope that will free humans up to be more, to have more time to either be more productive, be more creative, be more caring. Yeah. I really have a great hope for that. And then I think the challenge, especially in the face of something so powerful and societally transformative, the challenge is to not let that spare time or effort or energy be taken away very quickly. Yeah. And that's something I think we have to retain great focus on. And that's to do with retaining autonomy. But it's also to do with, I think, making sure that with whatever redistribution of resources that goes on, people who are ill-advantaged aren't further disadvantaged. Yeah.
Yeah. So that brings me one of the things that I remember when we started getting the internet, and it's this technology divide, right? And it seems that with AI, this is so rapid that we are seeing that, of course, among different generations. I mean, that's happening, but also among countries and within society, right? And you're bringing a topic that I think it's a very interesting one. And that could be a challenge for governments, importantly, but also for companies, right? That's creating like big distribution of competition. Competition is changing very, very fast too, in how it goes. But that's a whole new challenge that affects everyone. How do you deal with that?
It is, and I love the distinction between at a company level and between people, and so we've been. Two people that I've been finding inspirational are Eric Kaplan at Operation Hope and Ash Ramrachia at Academy. And so Eric at Operation Hope, they've been thinking about how to exactly tackle this problem of making sure that AI literacy among disadvantaged people in the US, but more globally, how it doesn't lead to increasing economic disadvantage. And it could be that because this technology is becoming cheaper and cheaper, AI, at least the inference mode of AI, is sort of being driven down to the price of the energy used to produce it. It could be a great equalizer. I think people do think that if you had a personal assistant that was extremely cheap to run, that could provide extremely high quality education, kind of decreasing an education gap is a way to decrease inequality.
Well, that's true too. That's another way to help with the same technology. I have a personal question on this because I've always wondering, will we get the moment where AI gets the emotional intelligence?
Yeah, that is such an interesting question. And so one answer I heard recently was, well, AI, before it will really be able to commune with us emotionally, it will have to suffer. It will have to suffer itself so it can understand suffering in others. And the way we build current systems, it doesn't seem like they suffer in the same way. But then again, how much of our emotional language is recorded on all of the content online? And in order for something like an LLM or an autoregressive model to essentially predict human behavior, maybe in its entirety, maybe it will have acquired a full understanding of emotionality. But I agree that I've always felt like that is the thing that has not really improved through all of the amazing advances in reasoning, etc. Is I still really feel like I'm talking to essentially a sort of a made-up algorithm. Yeah.
Right. Okay, what is the thing that you are more excited about right now in the field?
I am most excited about this idea of taking, like something that's kind of reactive on your computer or on your phone, and maybe can help you with search, to something that's proactive, something that's actively going out and making your life easier or more productive or more creative. Now, we think we know what that looks like through science fiction, maybe through video games, the sort of the prototypical personal assistant. But I'm really excited to see how that actually shapes out, and maybe what predictions from science fiction were right. Maybe we do really want like holographic personal assistants, and which were wrong,
Right.
Maybe it doesn't always have to be in like a sexy American voice. Yeah.
I love that part because I have the same question. Which one of the movies I've seen will turn into reality? Right. And what version of that will happen, right? They can be different. All right, well, thank you so much. I want to ask you two final questions before we end. We always finish with the same questions. And first, I want to ask you, you are now in this amazing project. You're running all these activities right now very successfully. What would be some of the lessons that you have learned in this journey that you would have wished to know when you started?
It's a great question, and everyone will learn their own, but I have two I would love to share with my former self. One is always do exactly what you want. Yeah. Don't let anyone tell you to or persuade you to, or even in a kind of soft way, make it felt that they want you to do something different. Or always follow your passion. And take that very seriously.
Now that's a very good one, yes.
And then the second is don't be too hard on yourself. Right. So I think that, like a lot of things you might ascribe to your own behaviors, but they were just random. Or a lot of things other people might do for reasons of their own, and maybe very deep-seated ones that they're not aware of, that don't really apply to you. So I think be really kind to yourself, love yourself, and then I think that the journey, whichever journey comes, will be more fruitful and enjoyable.
Don't be hard on yourself coming from a medical doctor and a PhD in AI. Okay, I get that one. I'll follow your advice. All right, so the final question is for people that are interested in this journey on to follow your activities or your organizations, what is the best way to follow you?
Well, you can follow me on my LinkedIn, which I believe will be shown on the screen. I think my organization, my nonprofit, Thinking About Thinking, has an increasingly active media presence. So if you look up thinkingaboutThinking.org or any social channel, that's a great way to find out more.
Thank you so much. It was a wonderful interview. Thank you.
Victor, a real pleasure. Thank you.